As I said, we're going to start with some tools and skills for quantitative thinking because these will be very useful for you as we move ahead, just to have a sort of a quantitative toolbox for you as we go. These will help you to solve problems and will be very key skills to have, especially in an exam setting in which they'll help you to move much more quickly through the material. The three things that I would like to make sure to cover are, first, scientific notation and how we write numbers and can use this in problems. Second, unit analysis, how we can just look at the units of key variables we'll introduce, an example of which is here, and which you do not need to memorize yet, and how we'll be able to use this unit analysis in problems and sometimes be able to solve entire difficult-looking problems just by analyzing the units in front of us. And then finally, I would like to introduce and help practice a key mindset, which is a mindset of proportionalities. Understanding how one quantity can depend on another in a particular way can help you to solve seemingly difficult problems very, very efficiently and quickly. So let's see what these three skills are. First, in the sciences, and certainly in physics, and it also will be the case in medicine, we deal with very, very big numbers. Sometimes these numbers have many digits, as this number right here does, before the decimal point, and sometimes they'll even be very, very small numbers. And because we don't want to write huge numbers all the time over and over again, we introduce a notation, a particular way of writing numbers. This way of writing numbers that we're going to use is called scientific notation and comes from the basic fact that in our system, which is a base 10 system, when you multiply a number by 10, it just gets a 0 added to it. We can use this fact to rewrite a number as big as this one just by moving the decimal point from one end all the way back. So instead of writing 2, 3, 4, and then a lot of zeros, we can just write 2.34 and tell you how many tens you need to multiply by to get back to the original big number. Practically, in order to do this, you just take your decimal point, move it over as many places as you need to, counting as you go, and however many places you needed to move that decimal point, that's how many powers of 10 you will need. In this case, we had to move the decimal point 12 places over, and so the actual number written in scientific notation is 2.34 times 10 to the power of 12. In scientific notation, we have a convention, which is that you always put the decimal point right after the first non-zero digit. And in this number, the first digit that is not 0 is a 2. And so we'll move the decimal place over until we've reached the 2, and we'll stop the decimal place after the 2. Once we've done that, we can write many, many big numbers in scientific notation. This will be very useful as we go forward. We get to see the usefulness of scientific notation immediately right now. Because we're dealing with so many big numbers and so many small numbers, we introduce some notation and some names for powers of 10 that we see very often. An example you might be familiar with is kilo, this 10 to the third on the first column you see on your left. This kilo is something you might have heard of with kilograms. We don't like measuring masses that are that small as grams, or maybe kilometers. Maybe a meter is too small when you're talking about something like driving long distances. And so we introduce a prefix, kilo, which tells us that we're talking about not meters, but thousands of meters or kilometers. As we go forward, in fact, the right column here, the ones with the lowercase prefixes, like deci and centi and milli, etc., are actually going to be more useful as we go forward in terms of how commonly they come up. Especially, I'd like to draw your attention to milli, micro, and nano. These are ones that are probably the least familiar initially for people, but also come up the most often, and so you'll want to really practice using those. In terms of writing numbers using this notation, what you want to do is take your number, say it's a very small number of seconds, like a millisecond, and instead of writing 0.001 seconds, you can say it is 1 millisecond. And the way you would write that unit, you can see in the far right column with the M. That letter M, you just put it in front of the letter S, and that will tell people that it's milliseconds. And you'll be able to see and use all these notations as we go forward.